A ball player catches a ball 3 seconds after throwing it vertically upward. With what speed did he throw it, and what height did it reach? So let's set this up. Here's the ground. Here's our thrower. We're going to throw a ball up. The ball's going to go up, come back down, and the thrower's going to catch the ball with their face right here. And we want to know with what speed did he throw it, so we want to know V0. And what height did it reach, so I'm going to call that Y max, the maximum height. And we know some other stuff. We know that the velocity at the top of the flight is 0, and we know the acceleration equals negative 9.8 meters per second squared. And we know that it took, the total flight time was 3 seconds. And so we can use all that, and there's multiple ways of solving this problem. What do we want to find? A, we want to find V0, and B, we want to find Y max. Or you can say delta Y max, that's good enough too. So let's solve. Now for A, I want to know what V0 is, and so I don't, and I know time, but I don't know what the final velocity is, and I'm not trying to find it. So I'm gonna try the third kinematic equation here. And by the way, some of you used a different equation for this, and that's fine. You got the right answer. So I'm going to do this 2 ways, actually. So if it goes up and down, well, we know that delta y equals 0 because it goes up and back down. So therefore, this is 0 equals V0 t plus 1/2 a t squared. So now I can solve for V0. So I'm going to put negative 1/2 a t squared equals V0 t, right? I just subtract that the other side and divide by V0. Or I'm sorry, divide by t. And so we'll get the initial velocity is equal to negative 1/2 a times t. And what is A? Negative 9.8 meters per second squared times time. Remember, this cancels that, so this is just going to be 3 seconds. And so this gives me, well, this negative cancels out, so 4.9, right, 1/2 of 9.8 is 4.9 times 3. And you get 14.7 meters per second. There's another way of doing part A, and that is if you realize, if you assume that the time it takes to go up is equal to the time it takes to go down. So if you start the problem here and let it fall down, you can solve for the final velocity, and then just say the final velocity is equal to the initial velocity, just in the opposite direction. But I don't know. Well, that's another way of doing it. Let's find Y max. Well, let's see, which one should I use? I'm just trying to think of what the best equation to use is, because we can pretty much use anything we want. We know the initial velocity, the final velocity, and the acceleration. and we're looking for delta y max, I'm going to use the fourth kinematic equation to do that. And this is 0. And, oh, I'm going to use delta y. So delta y is equal to negative v naught squared over 2a. Negative 14.7 meters per second squared over 2 times negative 9.8 meters per second squared. So that delta y max is equal to and you get 11.0 meters, not meters per second. You get meters squared per second squared divided by meters per second squared leaves just meters. So the units work out. Okay, so that's a couple of ways of doing it. You could also say, well, if the initial velocity is 0 here and let it fall down, you could use the third kinematic equation. And you should get the same answer. If you let it start here, oh, I'm off screen. Let me zoom out. You can use this equation to solve for delta y. If you start at the very top and let it fall down, and you say, well, at the very top, the velocity is 0. So v naught, if you start at the top, is 0. So that goes away. And so you just plug in 1/2 negative 9.8 meters per second squared times time squared. But what is the time from here to here? Well, it's 3 seconds divided by 2. It's 1.5 seconds. So let's see what we get when we do that. So 0.5 times 9.8 times 1.5 squared. And we get the same answer. Now, of course, this is going to be negative, isn't it? Because of the negative here. But what does that mean? That means that from here to here, it fell down 11 meters. Well, if it fell down 11 meters, that means it had to go up 11 meters, so our maximum height is 11 meters. So I would take this answer and just say max height equals 11 meters. So you can take something like this, it's got the negative on there, but say, okay, well, what does that mean based on what I assume to use this equation? And you say, okay, well, yeah, it fell down 11 meters, that means it went up 11 meters. So that's, you could have done this way, this way. You can also use time to figure out the initial velocity. You can use, if you assume that the velocity is 0 here, you can do that to figure out the initial velocity as well. But I don't want to take the time to do that because this has been going on for 10 minutes now. Any questions? Okay, that is all.